Good afternoon, everyone. Welcome to Getting Started with Kubernetes. I'm Blaze Stewart, and I'm going to be hosting this webinar online today. I am a senior consultant at Winelect, and my specialties are containerization and open source software. And I want to help you get started with Kubernetes. In this webinar, we're going to walk through a couple things related to this tech. But right off the bat, I want to just talk a little bit about who we are at Winelect. We are a consulting firm and an instructor-led training, and we do on-demand training. And we do consult on Docker technology and container technology as well as DevOps, as all this stuff is related to that. And we also provide training for this, and we are Microsoft's or have been Microsoft's #1 internal trainer for many years. And we also do online training, some of that related to Docker and containerization as well through our website, Winelect Now. We're a Microsoft Gold partner, and we have a partnership with Xamarin and so many other things. It's hard to talk about all of it, but just to let you know, we have these services available. And we also are one of the most respected consulting groups in the industry with numerous books to our name, and a lot of our guys have written books that you probably have on your bookshelf, including it's a classic by Jeff Procyse, and then one of the Core CLR by Jeffrey Richter, and several other books that have been just mainstay books for development for the last 10 or 15 years. And we are industry recognized experts in these areas. And just some other highlights about Winelect. We were a 2016 Gold Partner of the Year for Microsoft. Our CEO is a Microsoft Regional Director. We have multiple competencies, including DevOps, and we have several guys that are ALM Rangers, and we have Docker certifications, and among other things. And there's a lot of other things we could talk about, but enough about Winelect, and let's get right into the content. Okay, let me minimize. Let's get right into the content here. Okay, today's agenda, we're going to be covering Kubernetes, and I want to do an overview of Kubernetes, and then do several demonstrations about how to get started with Kubernetes. So the foundational knowledge is going to be critical to understanding all the tooling that's available on Kubernetes and how it all works together. So we're going to start with the foundation. So you'll have to bear with me a little bit. It's going to feel like you're drinking the ocean because there's so much to talk about when you're talking about Kubernetes. This is a very large piece of software, and we're only really going to get an inch deep into something that's very, very, very deep. So with no further ado, let's talk about the first thing, which is what is Kubernetes? Kubernetes at its core is a container orchestration software. And container orchestration, if you're familiar with that concept, good. But if not, it's a way of automating container workloads in a container environment. So the idea is that with containers, you want to get as many of those packed into a environment as possible. And the idea is that you could have potentially thousands of these things running on a given set of hardware. So it could be a single node or it could be multiple nodes that run as a cluster. So when you get to that kind of scale, you need something to manage that. So to meet that need, orchestrators were born, and there were several that kind of started out. And Kubernetes was one of those. Another popular one was Docker Swarm, and then there's DCOS. We're focusing on Kubernetes, but these other two have their place as well. So the purpose of these is to automate deployments so that you can run some scripts and it will actually automatically create the workloads for you. It'll monitor those and manage those, and it'll also scale those out as demand increases or scale them down as it shrinks. So this piece of software provides all of that functionality baked into a single package. So it's a rather large package. So you can imagine that there's a lot of things that you have to get under your belt as far as knowledge is concerned to even begin to use it. So Kubernetes is not something that's simple to learn, but it is learnable. So hopefully at the end of this video, you'll have a good head start and you'll be able to get it right into using Kubernetes for your containerization. A few other things about Kubernetes, it is open source. So everything that is part of Kubernetes is something that you can download. You can modify the source, you can add to the source, you can see the source. It's publicly available online. And it's seed technology by the Cloud Native Foundation. And this is important because it originally grew out of Google. Kubernetes was originally a Google product, but a few after the Cloud Native Foundation started, Google donated the code to the Cloud Native Foundation as well as continued to provide development for it. So it became a seed technology for that. Docker also donated some code to Cloud Native Foundation, which includes the Docker D or the Docker runtime essentially that runs Docker containers. So with the C technologies, now the Cloud Native Foundation is managing a lot of these technologies that are very container centric. So it's important to know who owns it because they are the ones that are going to determine kind of the pathway forward for Kubernetes and provide governance and so on. And there's a lot of members of that include companies like Google, Microsoft, and Oracle, and a lot of the big names in container technology as well. So let's start talking about the technical details of Kubernetes. The first thing to ask is what is a pod, which in Kubernetes there is a container. The containers are used by Kubernetes, but the most basic building block in Kubernetes isn't the container per se. It's actually something called a pod. A pod is what it does is provides a wrapper around a container or multiple containers to provide the abstraction that Kubernetes needs to scale things out. Now, you'd think, why don't they use containers? Well, Kubernetes by itself is not a container platform, it is a container orchestrator. So, in response to that, they needed to provide an abstraction around the container so that they could make assumptions about the pod and then adapt the pod to the container rather than to try to support all of the container itself, because there's more than one kind of container out there. The most common one is probably Docker containers, and probably 99% of everybody using containers is converging on Docker containers, but there's also other ones like from Rocket and some other companies that produce them. And Kubernetes does work with all of those different container technologies, but Docker is probably going to be the main one. And the other reason for doing pods is a pod enables you to deploy containers side by side and guarantee that they'll run on the same host. So a pod can have a main container for, say, maybe a web server, and then it can have what they might call a sidecar container that does some kind of workload in that container that's very specific to that web server and needs to be in the same environment as that web server. So you have multiple containers within a pod. So what Kubernetes does is it takes one or more of those containers, wraps them up in this concept of a pod, and gives you storage and networking, labels, and a name for it. Now the labels are important because what they allow you to do is gives you some way of providing some taxonomy to your pods. You can label anything really in Kubernetes, but the reason they add labels to pods is so that you can find things. So if you want to label them by layer or in a particular application, or you want to label them by application or version number or anything like that, you can use labels as a way of doing that. So labels become important when you start searching in Kubernetes for pods, services, and controllers, and we'll talk about those in a moment. But just the main thing to understand about pods is it's just a wrapper around a container that provides an abstraction for Kubernetes to know how to use the particular container. Then the pod is what actually is going to interact with the actual container runtime underneath. Now we have the name of the pod, the labels, and the storage. And their container uses containers for Docker containers. Now, another important concept with with Kubernetes is this idea of controllers. Pods are uh, different ways of clustering containers. The use cases, however, are managed by these things called controllers. Now, the pod is actually what contains the container, but a controller is what drives that process. So imagine that you have a controller that wants to create what they might call a replica set. Um, and a replica set is something that you deploy onto Kubernetes, and it uses a replica set controller to manage that particular set of pods. Now that is something that you want running continuously over time, and you want it to scale up or scale down and so on based on a set of rules that you define. And that's what the controller does for those pods. Another kind of controller might be a job of some kind. Now the job might be like something that runs on a schedule, something that runs on a trigger, and these jobs start, run, and then terminate. And the controller is a job controller that manages those pods. So in either case, you're still using pods and containers, but the controller is what controls the use case. And there's a lot of different controllers in Kubernetes. I've talked about two cases, two of the more common ones, but there's actually probably dozens of them out there, and you can even write custom controllers if you want for Kubernetes. But this is an important concept to understand so that you know which controller to use when you deploy your pods on Kubernetes. Now, another important concept on Kubernetes is the idea of a service. A service is essentially an exposure, a port exposure. So when we think about services in other contexts, we're thinking about web services, we're thinking about maybe a database service, we're thinking about something as a service. But in Kubernetes, it has a very specific meaning. A service is something, anything really, that's exposed through the Kubernetes proxy, and we're going to talk about that, all the components of a in just a moment. But anything that's exposed through the Kubernetes proxy to the to an endpoint that is accessible by users accessing that server. So suppose I had a database in a pod, or I had a database cluster defined by a set of pods. Now what the Kubernetes proxy will do then is take a port on the outside and then do a port forward to an internal port that is running on the pod. And it also does things like reverse proxies and forward proxies as well as load balancing as well. But anytime you map a external port to something that's a pod or a replica set through a load balance scenario, that's what Kubernetes is defines as a service. So that's important to understand when you start talking about services in the context of Kubernetes. So it can be confusing. Just make sure anytime you're talking about Kubernetes that you clarify, are we talking about Kubernetes services? Or are we talking about something else entirely? And that might be a service related to your software. So just be sure that you're talking about the same thing when you're talking about services in whatever context you're talking about. Now, I'm going to camp out on this slide for a little bit because I've got some takeouts on this. So I'm going to highlight the parts of Kubernetes architecture. Now, Kubernetes at its core is a clustering technology as well, and it provides all the orchestration and all the plumbing for doing um, clustering of nodes together. Now, what you would typically have in a configuration for a production environment is you would have probably at least 5 machines. Typically, you have an odd number of masters, so you need at least recommended would be at least 3 and at least 2 or more nodes. So at least 5 machines that are clustered together with maybe at least 3 masters and 2 or more nodes for redundancy, and you have these clustered together in such a way that if one fails, all the work can be shifted over to another one, or if your master fails, you don't lose the cluster and so on. So it's a clustering technology to provide redundancy. It's also a way of providing resiliency and as well. And at its core, Kubernetes provides all of the necessary orchestration to create a cluster right out of the box. It's not hard to do, but it's not a trivial task either to create a cluster. Now, the masters act as a controller, as a control unit for it. A cluster needs 1 or more masters to run, as I said. Recommended that you at least have 3 for redundancy. 2 is typically you don't want 2 in a master configuration because you ends up with when it elects a master, a new master, you need 3 so that you have an odd number. In case failure happens, you don't end up with competition between 2 other master nodes. Um, you want to create, and then the master is what controls that. Now you have nodes that are what actually run the actual workloads, and a Kubernetes node can have you need at least 1 to run, but in a production environment, yeah, at least 2 is recommended, probably more than that, depending on the size of the workload that you're going to be running. For our purposes, for developers and for testing and so on, you can actually install both a master and a node on the same computer, and it works just fine for development purposes. Now, you probably wouldn't want to do that again. Wouldn't want to do that in production. Um, we're going to talk about the pieces of the master here for a second. Now, the API server is what is the endpoint that developers interact with. Now, if you're using a command line utility or you're actually writing software that's going to work against a Kubernetes cluster that does some kind of orchestration, say you're writing scripts for Puppet or Chef or something like that, ultimately you're going to end up working through the API server, and that's the entry point for everything else from the administrative side. Now you also have the Coop Proxy, which we'll get to in a minute. That's the what the endpoints for your actual software are going to be hitting. Then you have this thing called the control manager. It manages all the controllers. Remember what we just talked about, all those controllers that you can have. You can have replica sets, or you can have jobs or what have you. And these various controllers are managed by the controller manager. So that's actually what runs all of those things. And what it does is it tries to deliver the desired state that's defined by the controller. And those rules will vary depending on the uh, the, uh, the the kind of controller you're using. Next, there's the scheduler, and then the scheduler is what actually does the orchestration and management of resources. So the controller is what talks to the API server, and then the API server is going to send something down to the scheduler. And the scheduler is what's going to be looking at the environment, saying, "Hey, well, I've got resources over here, I've got resources over there, and I can go delegate all of these things out to the various nodes on the cluster, wherever it may be running." So the scheduler and the control manager are what work together to kind of deliver the pods to the actual nodes that are running on the, the cluster. Then you have this thing called etcd, and this is an important component of Kubernetes. It was developed by CoreOS, and what it provides is a persistent store for configuration data on Kubernetes. And this in a multi-node configuration with multiple masters, the everything in the ECD is replicated across all the masters. So the configuration is not bound up to one particular master. It's replicated and it's accessible. So this is where all those labels are stored, all the names are stored, all the configurations for the controllers are stored, and so on and so forth is in etcd. And it's just a key value store database that you can use for setting up and organizing and configuring everything on Kubernetes. That's an important component of the master node. Now let's change gears and talk about the components of the node now. Kubelet is an agent that runs on each node, and it's what receives the commands from the scheduler and the controller through by way of the API server to do things on the node. So it's what's actually doing all the heavy lifting on the node itself. So it's what's going to pull images to the local node. It's what's going to start the pod. It's what's going to configure the port mappings. It's what's going to configure all of that kind of stuff on the local node. Now that's going to be replicated. Each node is going to have its own kubelet running across the infrastructure that you have deployed. Next, there's this thing called cAdvisor, which collects telemetry about pods running on the nodes and CPU and RAM usage, and it sends that data back up to the scheduler, so the scheduler knows what's going on side of in the node. You'll see it's not a it's more of a transparent thing. You're not something that you're going to really see, but it's important to know that it's actually there, it's running, that you need, and that it's doing something behind the scenes for you, so that the scheduler knows what's going on side of the nodes. Then there's the Kube proxy, which you've talked about a little bit already. Kube proxy is a network proxy and a load balancer that stands between the internet and or the network that the Kubernetes cluster is attached to, and all the pods that are running on that particular node. And it provides, like I said, load balancing and network proxying, so you can do port maps or you can do reverse proxies through it, like we've seen already through port maps. Um, it's an important component because it's also something that provides a lot of the infrastructure inside of Kubernetes that you wouldn't otherwise have inside of an orchestration environment such as Swarm. Swarm doesn't have really have that kind of a full-blown proxy like Kubernetes does. It does have a little bit, but it's this is one of the more sophisticated features that's inside of Kubernetes. And then we've talked about pods already. And lastly, there is this thing called the plugin network that uses drivers. Now, there's several different network drivers you can use inside of Kubernetes, and when you create a Kubernetes cluster, you have to specify which driver you're going to be using. Now, and they all have their strengths and weaknesses and use cases, but for most people, they don't really need to know that. As a developer or as a IT pro, the best one is just okay, pick one. Flannel seems to be one of the more popular ones, and it seems to be the most widely used. And what it does is it just provides what they call an overlay network between all of the nodes, so that you have a seamless communication. You can have seamless communication between your pods on different clusters. So if suppose you had a database that was running on in a replica set, so you have database redundancy baked into that replica set, and a request comes in for something on that database. Well, in one case, uh, that that you might have one instance of the database running on one node and another instance running on another node. But say that a pod that's running on one node makes a request and it gets routed to another node. Well, it's going to be doing that by way of the network that runs underneath. So you can have that network plugin to allow seamless communication between pods across nodes, which is a very convenient feature. So you don't have to configure all this complex networking if you have disparate environments, such as maybe you have a cluster that spans a hybrid network. You have a hybrid cloud on-prem network. You have one node that's in the cloud, and you have one node that's on premise, and you have a VPN, but then you have an overlay network that allows those to communicate seamlessly and so on. So the network is a very important part of this as well. So we've camped out a little while in this slide, and for a reason. It's mostly just to give you a good overview of the Kubernetes architecture and talk about the components and how they all work together. Again, it's apologize for all the jargon, but it's important to understand how all this works together so that whenever you go to start deploying things, you understand what's going on under the hood and what Kubernetes is doing for you. Because it can be, if you've been using Docker and you go to Kubernetes, it can be a little bit of frustration if you're not used to the way that Kubernetes works. Um, let's talk about tooling for a minute. There are three basic tools that you use to interact with Kubernetes. Now, there are certainly more than this. These are the three main ones that you deal with if you're dealing with Kubernetes on a regular basis. Well, the first one is the Kube ADM or the Kube admin tool. Kubernetes admin tool is how you use to set up. It was what you use to set up clusters. So in the event that I want to provision a cluster manually, I would use Kube admin to do that, or Kube ADM to do that. And that tool is what you actually run on your infrastructure, your virtual machine that you stand up Kubernetes on to start the process of standing up a cluster. Or if you want to add a node to a cluster or add another master to a cluster, you use the kubeadmin tool to do that. And if you want to remove one, you can use the kubeadmin tool as well. And it's the tool that's used for doing all that kind of work. Next, there is this kube CTL or this is or kube control. This is a command line interface for interacting with Kubernetes cluster. Now, this is the one that is the most often used by IT pros and developers for deploying things on Kubernetes. Now, if you're going to be the administrator, you're going to use kubeadmin. If you're going to be more the developer type or the IT guy that's going to be building scripts, or you're going to be rolling out containers and as pods to Kubernetes, you're going to be using CTL or kube control, and it's a command line interface. Uh, and it provides a lot of functionality for starting pods and creating services and creating deployments and other things on a Kubernetes cluster. And then lastly, there's a utility called MiniCube. And as a as a developer or as an IT pro that and you want to experiment and test and develop against Kubernetes, MiniCube is going to be your friend, because MiniCube is a utility that is used for creating small small Kubernetes clusters or standalone Kubernetes clusters on a virtual machine on your development box. And that's what I'm going to be using today to show you how you can get started with Kubernetes. I'm going to use MiniCube and Kube Control. I'm not going to mess with Kube Admin because setting up manually creating a Kubernetes cluster across a set of VMs is not a trivial task, and it takes several. You can do it as quick as 10 minutes or as long as a couple hours, depending on on your infrastructure and what legwork you have to do to even get ready for that. But depending on what you're doing, but for our purposes to get started with Kubernetes, I'm going to recommend that you use MiniCube to do a lot of that work for you, and then use Kube Control. And you can use Kube Control to interact with a Kubernetes cluster that you create manually, one in the cloud, or one that you use with MiniCube to create locally. So that's our tooling that we're going to have. Now, I want to just a note with these two, with Kube Control and MiniCube, you can easily install these from popular package managers such as apt-get, Chocolatey, or Homebrew. apt-get is for Linux. Or you could use Yum if you're on Red Hat, or apt-get if you're on a Debian-based distro. Chocolatey, if you're not familiar with Chocolatey, Chocolatey is a package manager for Windows, and it's it's fairly popular among for open source projects, and it works a lot like Homebrew or apt-get does on Linux, or Homebrew does on Mac, and you can just Chocolatey install and install a package from Chocolatey. And MiniCube and Kube Control are available through Chocolatey, or you can just download MiniCube directly from Google website where they maintain that. And then Homebrew, lastly, on a Mac, if you're familiar with Mac Homebrew system, you can use that to install MiniCube and kubectl as well. And these are easily downloadable. Just go out there, find out what the package name is through Google, and then install it, and you'll rock and roll really quickly. You can also install these manually, but I wouldn't recommend it because it can be rather arduous to get everything set up and correctly running before you get these things going. Okay, the first thing I'm going to use is MiniCube, and MiniCube is a utility for creating VMs for development and test purposes. So first thing I'm going to do is run this to show you that I have nothing running. I'm going to run MiniCube status, so it pulls up nothing. So to create a new one, you use MiniCube start. Now, to show you the options for this, I'm going to use -H to display the help, and I'm going to be interested in this VM driver. But first, you want to use to show you what versions that you have supported on this. You can do MiniCube and use this command, get K8s. K8s is a shortening for Kubernetes. So I go MiniCube, I do MiniCube, and then run this command right here to get the versions that I want to run. I'm going to be running this command later on, so I'm going to put that in my back of my memory buffer, but I'm going to be using version 8, so I'm going to use start to use that to run version 1.8 here. So now what I can do is I can just specify a VM driver, and by default it's using VirtualBox, so I didn't have to set that here, but if I were to do -VM driver Hyper-V, will use Hyper-V. Now there are other hypervisors available. On Mac, you have HyperKit, which is built into the Mac OS, or you can use VMware Fusion, or you can use VirtualBox there. And then on the Linux, you can use KVM or VirtualBox there. Now for the Windows environment, I would recommend using VirtualBox if you can. The reason being is it's a lot less buggy than Hyper-V. Hyper-V seems to have a lot of issues with this. I'm not sure why, but my experience is that sometimes it will create a VM, sometimes it doesn't. It's basically doing a wrapper around PowerShell and running a bunch of PowerShell scripts. So you have to have the right version of PowerShell installed, and then the right version of Hyper-V installed, and then maybe some additional plugins and so on. And it doesn't really bode well for an environment that you want to be reliable or less frustrating. So I've found that Hyper-V is not the best option, but on Windows, but VirtualBox is. I haven't had those kinds of issues on with any other hypervisors on Mac OS or on a Linux machine, but that's just a caveat of using it on Windows. Now that this is created, I can do MiniCube status again, and then get the status of my box, and there's the IPX running. Now I can also use MiniCube to pull up the dashboard, and this is the UI that I was going to do a demo for later on, but I'll go ahead and start this up. Now, MiniCube by default will start the VM, but doesn't mean it starts all the services, and sometimes the services can take a minute to start too. And because the service isn't readily available, this might take a minute to pull up. It's because in the background, Kubernetes is still starting up some of its the components. You remember from our demo that it had a lot of stuff that was running. I got a bug here, an error. Let's try that one more time. It says it's not ready yet, so sometimes it times out or waiting for the endpoint to start. So as soon as this comes back up, we'll should be able to see the endpoint, and that will show you what's running on this particular instance of MiniCube or Kubernetes, and started by MiniCube, and here it is. And this is the status board. So notice I don't have anything running as of yet. I don't have any jobs, no pods, deployment services, cron jobs, and these are all the various controllers that you can have on here. And I'm not going to go into detail as to what those are. You can look those up, but these are the various things that you can run. Now, I'm going to deploy the pod here, and in just a second, it's going to create a deployment and a replica set. So it's going to use those abstractions on top of the pods to create different kind of controllers for those. So let's go back to the command prompt, and I'm going to switch over to kubectl. Now, kubectl is the command line utility for interacting with a cluster. So if I go kubectl and then I go run -h, this is how you create a pod or a container. So I'm going to run the Nginx, and that's probably the textbook case for this. I'm going to call this Nginx, and then I'm going to use the image Nginx. Now what this does in the background is it sends this off to the Kubernetes cluster, which then uses the API manager, API server to go to the the controller manager to get the replica sets, and then goes to the scheduler, which then sends it off to Kubelet, and then Kubelet pulls the image and starts the container. So I'm going to expose port 80 on this since it's a web server, and run this. I forgot the run command. So run Nginx. Now, if I go back over here to my UI, I should now see that the replica set is running. There's my pod, it's just one pod. And now I have deployments too. So it looks like everything is kosher. And here's the events that I did in the background. If I go down here to my pods and I click on this, you should be able to see the events related to it. You got the assignment from the scheduler, and then the kubelet did amounted a volume for the storage, did the pulled the image, created the container, and started the container, and then everything's running there. So let's go back over to the command line. Now I'm going to create this service again, and use this command that I had in my buffer right here, because I always forget this command for some reason. I'm going to call this Nginx for my Nginx service. Now what this is going to do is it's going to expose the Nginx through the Coop Proxy. Now I'm specifying as a load balancer because I have a replica set behind the scenes here. And I'm going to specify my deployment of Nginx that I just ran in the last command when I ran it. So expose the deployment Nginx as a load balancer and give it the name of Nginx service. Now, if I go back to my Kube UI here, I should be able to see the service now down here. And notice it's running right here, and though it's put it up on this port right here, so I can use this port if everything goes well. I should be able to use 192.168.100 and plug that port in and see Nginx running. So that's because it's proxy through this port, doing a reverse proxy back to port 80 on Nginx. So that is a short demo of how you can deploy services using using Kubernetes very quickly. Now there's a lot more to it than that. Obviously this is more of a hello world type demo, but there's a lot more you can do with it than simple command. There are several ways to run Kubernetes in a production environment, but probably the most efficient way to do that is, or probably the easiest way I should say, is to use a cloud hosted environment such as Azure Container Services, or AKS, which is Kubernetes deployed on in the Azure cloud. And what that enables you to do is to to go out to Azure's portal, or you can do it at the CLI and spin up a Kubernetes cluster without actually having to configure it yourself. And you don't have to worry about any of the virtual machines it's running on or any of the underlying hardware. Microsoft manages that all for you through their management services. So all you really have to do is focus in on actually managing the Kubernetes cluster and not to worry about the virtual machines that it's running on. So it's very easy to do. Also, recently, Docker integrated Kubernetes into Docker EE, so you can use that with native support right out of the box with Docker EE, or you can roll your own Kubernetes out of the box with a kube admin like we talked about earlier in the presentation. So that's some ways you can run it in production. And there's a lot of different ways that a lot of different companies that offer services related to Kubernetes, and you can run those on line as well, either through OpenShift or you can use Google Compute or Amazon Web Services, what have you. But I think Azure Container Services was one of the first out of the gate with a fully managed platform for running Kubernetes. So therefore, you can run Kubernetes, run your container services there. And lastly, I wanted to open the floor for questions, but there's a few things that you can do is check out our dev center on oneelect.com with a great number, for great container related content. You can also email me questions at bstewart@oneelect.com, or you can follow me online at the One Mule, or you can let us help us make your container story a success with instructor-led training, with Docker, Kubernetes, DevOps, and much, much more. Consultation for containerization, Docker, Kubernetes, and DevOps as well. Well, thank you for attending today's webinar, and I hope to see you online in a future webinar.